This video is about hypothetical syllogisms. Hypothetical syllogisms are like, and I think I might have called them this, conditional syllogisms. You see this distinction between categorical and hypothetical. There's a certain explanation of this in Bennett that I'm sure is perfectly fine in terms of categorical syllogisms being about whole categories of things or whole classes of things. I like to think of categorical, or get my understanding of what categorical means, by opposing it or distinguishing it from hypothetical or conditional. So if syllogisms are composed of statements of certain sorts, let's look at the kind of statements that categorical as opposed to hypothetical syllogisms are composed of. Categorical syllogisms are composed of categorical statements. Categorical statements are simple statements that have no conditions put upon them. They are unconditional. If we look at this one here, all people love flowers. It's a categorical statement. There's no conditions put on that. It's just a straightforward statement about people, and it assigns a certain characteristic to all people, that they love flowers. I think that some people love flowers is also a conditional, or excuse me, a categorical statement, and I think that that's true. It's just a straightforward statement assigning a certain characteristic to a certain class. Here's a conditional statement. If something is a person, then it likes flowers. Logically, it's equivalent to this, but it's put in a different way. If something is a person, then that something likes flowers. But we don't know if that something is a person. There's an if. There's a condition that would need to be fulfilled in order for the statement to be true. So a hypothetical statement is a conditional statement. And here we have the condition expressed by the if and the then. So here's a categorical syllogism. All people like flowers. Jim is a person, so Jim likes flowers. That's categorical. Here is a hypothetical syllogism. If the team wins, we will have cake. The team does win. The team wins, so we will have cake. This is the simplest form of the hypothetical syllogism, where we state a certain, in our initial statement, we have a statement that sets a certain condition. If the team wins, then we will have cake. We fulfill the condition. The team does win, so the statement then, that the consequent is then fulfilled. We will have cake. So what is that general form? If P, then Q, or if P is true, then Q, or then Q is true. P is true, so Q is true. That is the sort of classic modus ponens form. Modus ponens, the mode of affirmation, something like that in Latin. Not all that important to know the Latin, I guess, but it doesn't hurt to associate this, to give a name to this schema, or this argument schema, or syllogism form. If P is true, then Q is true. P is true, so Q is true. Modus ponens, affirmation. And here's the affirmation of the antecedent. Here's the other valid form that we're introduced to here. If P is true, then Q is true. Well, Q is not true, so P is not true. That is, we know that Q, or Q being true, is a necessary condition for P being true. So that if Q is not true, then P cannot be true either. That is, I guess, the mode of denial, denial of the consequent. If a necessary condition for something being true is not true itself, then that thing can't be true. So Q is not true. These are valid forms, right? It's important to learn the sort of classic fallacies that also are involved in a hypothetical syllogism. Here's our hypothetical statement. If P is true, then Q is true. Well, Q is true, so P is true. That is fallacy. It's called the fallacy of affirming the consequent. Now, why is this a fallacy? Well, think about it. Q is a necessary condition for P, or Q being true is a necessary condition for P being true, but it is not a sufficient one. So we know that if Q is false, then P can't be true. But just because Q is true does not mean necessarily that P is true. So to conclude on the basis of Q being true that P is also true would be a fallacy. That is the fallacy of affirming the consequent. Let's look at the other classic fallacy here. Well, if P is true, then Q is true. Well, P is not true, so Q is not true. Now remember that P, or P being true, is a sufficient condition for Q being true, but it's not a necessary one. So it's still possible for Q to be true if P is not true. So to conclude that Q is not true on the basis of P not being true would be invalid. So this is the fallacy of denying the antecedent, thinking that because you deny the antecedent that you can also deny the consequent Q, and that is a fallacy.